Welcome to IS at Speed of Light, and from this lecture, we are going to start with the physical geography concepts. Now, one particular book which we need to follow for this physical geography concepts, it is the Gi Shing Long Certificate Physical and Human Geography, and also the NCERT Fundamentals of Physical Geography. These two books are more than sufficient, and we need not go through any other book just for the general study. So these two books, along with the current affairs part, which we get every day in the newspaper regarding physical geography. So let's start with physical geography, and our first topic or first fundamentals which we will see is for the atmosphere, is for the weather, is for the climate. And now to understand how this weather functions, how this climate functions, we must understand the sun-earth relationship, because sun is the only source of energy for earth, and it is this energy which is actually making different climate and different weather for us at different parts of the earth. So let us see now earth and sun together from a distance, right? And earth position at different parts at the different times of the year. So here we have sun in between, and here we have earth in its elliptical orbit. Right, so now what this elliptical orbit it is doing for Earth is, at one point of the year it is closer to the Sun, and other point of the year it is farther from the Sun. Let's go to this point where it is closest to the Sun, and this point we call as perihelion. Perihelion means being closer to sun. So it is the closer to the sun, our earth. Now this is contrary to what we believe. This is the winters for the northern hemisphere, or it is the winter solstice. This perihelion, it happens on 1st of Jan every year, and it is the winter solstice. It is the winter solstice for northern hemisphere. Now the reason why it is winters for the northern hemisphere, in spite of being closer to the sun, is the tilt of the earth, which is making the northern hemisphere getting tilted away from the sun, which is the source of energy. So in this case we can see here the northern hemisphere, this is the northern hemisphere and this is the southern hemisphere. Northern hemisphere is tilted away from the sun, so it is getting less heat. Vice versa with the southern hemisphere, which is now tilted towards the sun, it is experiencing its summers. So this is one point of the year. Now let's switch to the other point of the year, and this point we call as aphelion, and it happens roughly on 1st of July. Now this point of year, as we can now see, the northern hemisphere, this is the northern hemisphere, it is tilted towards sun, so it is experiencing its summers. So it becomes summer solstice. Winter solstice, it happens between 20 to 23rd of December, while summer solstice, it happened between 20 to 23rd June. Now these dates are the rough dates. Sometime perihelion, it can happen on the 1st, 21st of 31st of December, or maybe 2nd of January. Similarly with aphelion. So summer solstice, winter solstice, perihelion and aphelion. So we are having winters, the winters of the northern hemisphere, when we are closest to the sun. Vice versa in southern hemisphere. So these 2 points of the year, we have two different seasons, the winter season and the summer season, and we understood the reason for these different seasons. It is the tilt of the earth. This tilt of the earth, here we introduce another term, which is axis parallelism. So what it means is the axis of the earth, it points in the same direction throughout the year, throughout its revolution around sun. So what it does is it makes it possible for different climates or different seasons at the different parts of the earth whole around the year. So solstice means to change. Now we introduce two other points around sun. So you just draw with me here. So here we have earth. This is perihelion, this winter solstice. This is the summer solstice for the northern hemisphere. Now we see to another point during the revolution of earth, and these are the equinox. These are the equinox. So equinox, equi means equal and nox means night, so equal nights. So this is the vernal equinox, and this is autumn equinox. So what happens during these equinoxes, it is you will have the whole earth will experience the equal day and nights, that is the 12 hours day and 12 hours night, no matter which part of earth you are in. So you will have equal nights and equal days, 12 hours day, 12 hour night. This vernal equinox, it happened between 20 to 23rd of March, and autumn, it happens between 20 to 23rd September. So we have seen four different points of the earth when earth is closest to the sun, and this time we are having winters. Why? Because of the tilt of the earth, northern hemisphere is getting away from the sunlight, right? The opposite side of the orbit, which is the aphelion, which is the summer solstice or the summers for the summers for the northern hemisphere. And why it is summers? Because this time the northern hemisphere is tilted towards sun. Let's understand it a bit better. So this is the orbit, right? And here we started with this point, which is the winter solstice. Here, we can see here now this is a north pole and this is a south pole. So this time we can see this is the shaded region, right? So this is a shaded region, and north pole this time is experiencing 24 hours darkness. 24 hours darkness for the north pole, and this is the winter solstice for the northern hemisphere. Similarly, during this time we can see this is the south pole and it is getting 24 hours light. Right. Let's move to the other point, which is the summer solstice, right? So this time the earth tilt, it is making it in such a way that this portion, this north pole, it is getting 24 hours light, while this south pole, it is in 24 hours darkness. While these two springs and fall, that is vernal equinox and the autumn equinox, it is making 12 hours day and 12 hours night, no matter where you are on the earth's surface. Right? So these becomes the important points during the earth evolution. We started with the winter solstice when earth is tilted away, the northern hemisphere is tilted away from the sun. So the North Pole is experiencing 24-hour darkness, and it is the winters in the northern hemispheres, while it is the summers in the southern hemisphere. Then we move to the other different point where the earth is now making northern hemisphere getting tilted towards the sun, making it's a summer solstice for the northern hemisphere. And during this time we can see this part, the north pole, it is having 24 hours light, sunlight, and similarly the south pole is having 24 hours darkness, right? And the two equal nights and days region, that is the springs and the fall. Let's move further and let's explain this concept of Earth-Sun relationship in a bit more detailed way. Now just draw with me. This is our Earth. Now we are going to talk about the five important parallels, which are the imaginary lines which have been developed with the convention of the culture. So let's start with the middle line, and this is we call as the equator, which is actually dividing the earth in two equal parts, that is the northern hemisphere and the southern hemisphere, and this is 0 degree north and south, and it is equator. We draw another two lines which are 23 degree 23.5 degree north and 23.5 degree south. Now the reason why these lines are there, this 23.5 degree north and 25 degrees south, it is because this is the full extent for the direct rays of the sun. Right, so direct rate of the sun, it cannot go beyond 23.5 degree north and 23.5 degrees south. So this is the reason why these lines are there. We will get into a bit detail for this momentarily. Let's move ahead and draw our next parallel, which is 66.5 degree north and 66.5 degree south. Now that's why we have made the 66.5 degree north and 66.5 degree south an important parallel because this is the full extent for the oblique rays of the sun. Right, so direct rays of the sun between 23.5 north, 23.5 degrees south, and the oblique rays between 66.5 north, 66.5 degree south. This 23.5 we call as Tropic of Cancer, this we call as Tropic of Capricorn, this we call as Arctic, this we call Antarctic. Then we have North Pole and South Pole. And so these are very basic things we all know. Now let's see what these direct rays means and what these oblique rays means, right? So here we can see this is the North Pole and this is the South Pole. And we can see here this is the summer solstice where the northern pole is getting tilted towards the sun, and this is the North Pole which is in now 24 hours sunlight, and South Pole which is 24 hours darkness. So this time of the year we are getting direct rays on Tropic of Cancer. So direct rays is on 23.5 degree north. Similarly, now as the season will change, direct rays will come to 23.5 degree south. So this becomes the extent, the full extent for the direct rays of the sun. Now just draw with me. This is our Earth. This is Sun. This is the Earth axis. This is the equator, right? And these are the parallels. Tropic of Cancer, 23.5 degree north and 23.5 degree south. Now we can say here this is the winter solstice where the North Pole is tilted away from the sun. This is the winter solstice. So this time we have direct rays of the sun on 23.5 degree south. Now the reason why we draw 66.5, let us see now what was the reason for that. Now this 66.5 degree north, it becomes the extent for the sunlight and darkness. So here this 66.5 degree north to 66.5 degree south, it becomes the full extent for the darkness and sunlight. So here this south pole, it becomes 24 hours sunlight, and this north pole, it becomes 24 hours darkness, because it becomes the shaded part with 66.5 degree north to 66.5 degree south. Let us now again switch to the next part of the year, where this is the sun and this is the earth. Let's draw the equator now, and let's draw the two parallels, which are 23.5 degree north and 23.5 degree south. Now here this is the summer solstice, which are the summers for the northern hemisphere, and northern hemisphere, it is tilted towards the sun. So here we have direct rays of the sun falling on 23.5 degree north, and here we have again that imaginary line, which is 66.5 degree north, and from 66.5 degree north to 66.5 degree south, it again becomes the extent for the oblique rays, and beyond that we have darkness. So here we have northern hemisphere, which is now having 24 hours sunlight, and southern hemisphere, which is having 24 hours of darkness. And now as the earth moves in its elliptical orbit, and this was a winter solstice, it was a summer solstice, and these two are the equinoxes. So during equinoxes we have direct rays of the sun falling on the equator. So with this changing of the sun's direct rays or the oblique rays on the earth's surface also shifts the complete climate and the weather phenomena and the other wind patterns, other wind circulations, which we will see in some time from now. So this is the parallels, important parallels of the earth. We saw their purpose: equator dividing northern and southern hemisphere. Then we saw the Tropic of Cancer, Tropic of Capricorn, which is 23.5 degree north and south, which are the full extent for the direct rays of the sun. Then we saw another parallels, which are 66.5 degree north and south, Arctic Circle and Antarctic Circle, which forms the full extent for the oblique rays of the sun. So this becomes the oblique rays of the sun, and this part we join to show the extent for the darkness and for the daylight during summer and the winter solstice. This another is an illustration when the northern pole, it becomes a summer solstice. Northern pole is tilted towards the sun, So here we are getting 90%, that is the direct rays of the sunlight on 23.5 degree north, which is the Tropic of Cancer, right? And the full extent for the oblique rays till 66.5 degree north to 66.5 degree south. And beyond that we have complete darkness in the north, in the south pole, and complete daylight in the northern pole. Let us understand one more thing. What is the difference between the direct rays and the oblique rays? So direct rays, oblique rays. So what is the difference between these things? Now suppose you're having a torch with you and you are making it focus on the smaller part. So now this part, it becomes an intense light. intense light or light with more energy. Similarly, oblique ways, when this similar torch is you making it to give light on the large surface area, the intensity of the light becomes down. Intensity goes down. Similarly, here intensity becomes high. So similarly, same thing is happening with the Earth. Now between 23.5 north and south, you are getting more intense heat rays from the sun, and comparatively less heat from the sun by its oblique ways between 66.5 degree north to 66.5 degree south. So as you are going from equator to the poles, it is getting colder. It is getting colder. So tropics, we see the maximum number of heat, like, so it all fits in. If we see of the earth, equators are the hot, right? Tropics are the hot, and as we go from the tropics to the poles, it becomes cooler. So all things fits in between. So this becomes our first fundamental lecture, and becomes really important and very easy to understand also, the earth sun relationship, how earth, because of its elliptical orbit and its tilt from the earth, it is making the summers for the northern hemisphere and the winters, and it is different for the northern hemisphere and the southern hemisphere, and how we have defined the different parallels on the earth, what are their purpose. The tropic of Cancer, the tropic of Capricorn, these, between these two we have the direct rays of the sun falling. So this is the full extent. Direct rays of the earth, direct rays of the sun cannot go beyond these two parallels. Then we see the Arctic Circle and the Antarctic Circle, which are the full extent for the oblique rays of the sun.